We're beginning our discussion right now, and we are looking at the Cartesian plane. Cartesian plane below. Triangle OAB has vertices, O as the origin, A has those coordinates, and B those, okay? Calculate now the gradient of OA. We need the gradient of OA. What is the gradient of OA? So we agree that the coordinates are 0 and 0. So if you're looking at OA, we can call this x1, y1, and we call this one x2, y2. What is then the gradient of OA? So which means the gradient of OA is y2 minus y1. What is y2? 4 minus 0. x2. 2 minus 0. 4 divided by 2 equals exactly 2. And therefore, we're interested in finding the size of the angle AOB. AOB. What is the size of the angle AOB? Right. So we are interested in finding the size of this angle here. So if that is the case, we know that the angle there, the tangent of the angle of AOB is equal to the theta, rather 2, so that AOB is arctan 2. What is arctan 2 using calculator? It's 63, 43 degrees. It is 63, 43 degrees. And we have this. Right, so we've been able to find the size of the angle AOB, and the gradient has been found, and the marks are 4 allocated. Next, we need to determine the equation of the perpendicular bisector. Perpendicular bisector of OA. What is the equation of the perpendicular bisector of OA? Right, so now to find the perpendicular bisector of OA, we need a couple of things. First, we need the gradient of the line perpendicular to OA. What is the gradient of OA? Is 2. Right, so the gradient of OA is 2. And the gradient of the perpendicular bisector is minus 1 over 2. Because when you multiply them, you must get negative 1 because they're perpendicular. So the bisector, if you have a line like this and you are speaking about a perpendicular line segment, and you're speaking about a perpendicular bisector, you therefore have the bisector. The bisector means that you are looking at the midpoint. The midpoint of these here is 0. So you take this one plus this one over 2, which is the midpoint. So here you are looking for the midpoint. Then you have 0 plus 4 out of 2, which is 1, 2. 1, 2. So it's the perpendicular bisector. It's the midpoint. At the point of bisection. So therefore, if you realize that this one has the coordinates 1, 2. Y minus y1 is m into x minus x1. This is passing through 1, 2, xy. Right. So we have this. Y minus y1 equals m. Perpendicular is minus 1/2. X minus x1 is 1. So it's minus half x plus 1/2 plus 2. Minus a half plus 2 plus that is 2.5, which is 5 out of 2, if you like. Right, so that is the equation of the perpendicular bisector. So you need
Sir,
to learn.
please explain it again.
Okay, right. So obviously we're speaking about the equation of the perpendicular bisector, and I just obviously brought this question so that you can understand the idea of a perpendicular bisector. Right, you learn about the line OA in the diagram. O is the origin, and the point A has the coordinates exactly 2 and 4. And we want to find the equation of the perpendicular bisector. So in mathematics, the word bisector means that you are dividing into two equal parts, and the prefix bi means 2. Bi means 2. So right, so we're speaking about the perpendicular bisector. So the bisector cuts in the middle. So we are looking for the midpoint. The midpoint here would be the same here. So the formula for the midpoint, x1, x2 over 2, and y1 plus y2 over 2. This is the midpoint. This is the midpoint. So if this is the case, then you have x1, y1, you have x2, y2. So x1 is 0, x2 is 2. So x1 is 0, x2 is 2. You add them up, you divide by 2, and then it's 1. Right, then we have y1 is 0, y2 is 4. Right, so in the end, you have the midpoint. What is the midpoint? Right, so use the formula. You take x1, x2, so you have 0 plus that over 2, and you take y1, y2. y1, 0, y2, 4. 0 plus 4, you divide by 2. And what you're getting here, divide 2 by 2, you get 1. You divide 4 by 2, you get exactly 2. And hence you have the 1, 2 midpoint. So obviously it means that this line that is perpendicular, not only perpendicular this line segment, but also bisects, is such that it passes through the midpoint 1 and 2. So, which means that now we know the gradient of the perpendicular, which is minus 1/2. So, but it passes this line that is the perpendicular bisector passes through 1, 2. So, from which we're able to get to the x1 and y1. We put y1 here, which is 2 minus 1/2 x minus x1 is 1. So, which means it's minus a half x plus half plus 2. So, y is equal to minus a half x plus half plus 2, which is 5 over 2. Right. So, we have that. So, that is exactly the answer, the equation of the perpendicular bisector. This question I just brought has a lot of the perpendicular bisector questions and other concepts in geometry that will help you step up your understanding of coordinate geometry, or what we call analytical geometry. Okay, next. Write down the equation of the perpendicular bisector OB. Where is OB? Now they want us to not to calculate, but to just write down the equation of the perpendicular bisector of OB. Let's look at the line OB in the diagram. Right, so we have OB and want the equation of the perpendicular bisector. So OB is this, and therefore the perpendicular bisector must cut in the middle because it's a bisector. So it must cut Yeah, and perpendicular. So if it cuts in the middle, we need to find the midpoint. So the midpoint is obvious. You just take this one and this one. 0 plus 6. Right, so 0 plus 6, you divide by 2. 0 plus 0, you divide by 2. In which case, you have 6 divided by 2, which is 3, 0. So it is 3, 0. Okay, that is the 3, 0 point. So what is the equation of this line that passes through there? It's perpendicular and it bisects this. It does this. Right, it passes through x equals 3. So the equation is only x equals 3. Okay, because it's vertical. Right, so it's the equation of vertical line. And so what is that equation? Right, the equation is clearly x equals 3. Okay, so they're just bringing some perpendicular bisectors there. So those are the kinds of things you need to realize. Determine the equation of the circle passing through O, A, and B. Right. How many marks is this one? 5. Right, so we have these. The equation of the circle passing through O, A, and B. Let's look at the diagram. The circle passing through O, A, and B. Okay. So there's a circle we can draw that passes through those points. We need its equation. But to find the equation of the circle, we need to identify the center of the circle. We need to identify the center of the circle. What is the center of the circle? Right, obviously you need to think about this and understand what is happening here. Right, what is actually happening here? Right, so you think about this very carefully and think about what is happening. Okay. Right. So what is actually the equation of this circle here? Right. So a couple of things then remain critically important here. You already have the equation of the perpendicular. This equation we got. The equation of the perpendicular bisector of OA. The equation of the perpendicular bisector of OA. Right, we already got that one. And so if we found the equation of the perpendicular bisector of OA, and then we got the equation, and the equation was like this. So this is geometry. So now this is creative from the examiner. Okay, so perpendicular bisector. There's another perpendicular bisector here, and therefore these two guys meet at the point. So when they meet at that point is going to be the center of that circle. Okay, that point is going to be the center of that circle. So we will need to find the coordinates of these points. But we already know the x there at this point, because to find, now if they ask a question like this in the exam, so you want to find the equation of the circle that goes around a triangle. Okay, so this sort of what it does is it actually circumscribes the triangle. It actually covers and bounds the triangle. And therefore, we already know our x is 3. We need to get the y, but you know that y is, yeah, the equation of this one. We said it's minus a half x plus 5/2. So which means that x is 3 and y is like this. What is 5 minus 3? 2/2. 2/2 is 1. So which means you have that the center, the equation, the center of that circle is 3 and 1. Right, so want to find the equation of that circle. Once again, as I said, that the x is 3 at the center, and then but y is given by the minus a half x plus 5 over 2. And we write down the answer like this to the exam question. X is 3 plus 5 over 2. What is 5 minus 3? Is 2 over 2. 2 over 2 is 1. So, and that means that the center of that circle has the coordinates 3 and 1. Right, so we know the equation of the circle is x minus a squared, y minus b squared equals the radius squared. So x minus, what is the a? A is the first one, so you square the a, and then the b is 1, you square, okay? This one is a very conceptual question, highly conceptual. You square this, and it is now the radius. The question is, what is the radius of that circle? Because the perpendicular bisectors of the triangle will meet at the center of the circle. Now, what is the radius of that circle? Right, so we need to find the radius, of course. We don't know what it is. Let's just leave it as r squared. Right, so we need a point through which the circle passes. The circle surely passes. It passes through the points O, A, and B. Which one is easier to use? We must use any of the points. The origin is easier to use. We can use A and B, but 0 and 0 will be the easiest, okay? So you have that one squared plus 0 minus 1 squared equals r squared, which means r squared equals 1 plus 9, which is r squared. And therefore now, you have this one squared, you have that one squared equals, what is r squared? It's 10. So in the place of r squared, you put 10. So we have that one. This is the equation of the circle they wanted for a beautiful 5 marks. So just pay particular attention to this here. Right. So that is the answer to the question. Look at these very carefully. Right, and make sure you understand this, because I'm going to give you some short tests after today's discussion so that you can show me what you can do. Right. Right. Yeah. So we move to the next question. Some more question I'm going to give to you. As you go along. Right, I'm going to give to you as we go along. So yeah, next question. Let's look at question 3. If the sine of 31 cosine 22 plus sine 22 cosine 31 equals k, then without the use of a calculator, determine the value of the following in terms of k. Sine 53. What do you think the answer is? You're the only one now. Okay, the rest of the guys are busy. I spoke to other students. Okay, so I'm asking you just because now I was gonna, yeah, you're gonna share the responsibility. So you're gonna be like, okay, guys, yeah, anyone. But yeah, I spoke to the guys. Some guys said, okay, we're gonna make it at 5 the morning. We're still playing sports. We're still doing extra murals. So I then said it's okay, right? So, your thoughts, please, on this. You just say what you think. It's not a question of getting 100%, but it's a question of trying.
Let me read again.
Okay, please read the question. You can even read it aloud. You can even like talk the question. Okay. Because this year's exam is going to be a little bit tough. It's going to be a little bit tough. So you need to prepare for war.
Sure. I don't even know. And it's just 1 mark.
It's just 1 mark. Never mind. I'm just teasing you because I'll always tease you to try a question. Okay, but now this one is obvious because they're asking us to enjoy ourselves. You need to just remember that this, what has been given here is like the sine of alpha is sine something, cosine something.
It's like an identity.
It's like an identity. Well done. It's like an identity. I'm trying to write the identity. Okay, if we write this identity, it's at the back of the metric paper. Okay, so if we write
Yes.
sine alpha cosine beta plus sine beta cosine alpha, what is this the same as? It is exactly the sine of alpha plus beta. Right, the sine of alpha plus beta is always sine alpha cosine beta plus sine beta cosine alpha. So if you use a sine identity, it's always sine cosine, sine cosine. You can say also cosine sine, right? So it's the same thing. You can write it like that one. Okay, good. Good, good, good. So now what is this? Because now we have to expand this. So the examiner gave us the sine of 31 degrees, cosine 22 degrees, plus the sine of 22 degrees, cosine 31 degrees equals k. What is this? So if it's long, if they give you this long thing, it can be written like this. So we just write only a single trigonometric sign, and then we add the two angles. We add 31 degrees and 22 degrees. Okay. What is 31 and 22? It's exactly 50 degrees. Meaning that the sine of 53 is k. The sine is k. You get the point? Right. So
Yes, I
yeah, very nice and easy. Let's look at the next one. What about cosine 143? Now it's a bit 2 marks here, so yeah, there need to be a bit more steps. So 143 can be done in 2 ways. So you always think about, because there's 53 we got, it's 53 we got. So if you say 180 minus, or you say 180 plus, in which case you can say this is equal to the cosine of 90 degrees plus 53. 90 degrees plus 53. 90 plus 53 is what? Is 143. But in which quadrant is 90 plus?
the second quadrant.
Well done. In the second quadrant, in the cosine is what there is negative.
Negative.
Negative, but it changes to its co-function using the Coco rule. Using the Coco rule, changes to its co-function, giving us the sine of 53. What is this? What is sine 53? It is k, so it's minus k. So the answer is minus k. The next one is yours. Okay, I'm going to do some and give you some because you like practicing. It's exam prep. It's exam preparation. Right, so now let's look at this one. Now you have sine 75, sine 22 plus cosine 75. Now we need to deal with this. What is the answer to this? That is the question. Okay, the question said determine the value of the following in terms of k. So in terms of k, the Greeks say kappa. Kappa. We say k in English, but yeah, the Greeks say kappa. Okay, right. So what is the answer to this? Right, it looks very long, but you need to remember the identity that says that if you have the following, if you have cosine alpha cosine beta plus sine alpha sine beta. So we know this identity. Okay, this is the same as cosine of alpha minus beta. Cosine of alpha minus beta. So at this point, then it is the same as cosine of, okay. Now if it's cosine this, so this is like alpha and this is like beta. The first one is alpha, the second angle is beta. It's the beta is like B with a tail. Right. So now you need to say the first angle, alpha, 75 degrees minus the second angle.
Going to give us 53.
Well, then it's going to give us a 53, which is something we know about. A 53 has been like appearing many times. So we know something about it. So it's 53 degrees. Good. So if it's cosine 53, then what is the answer? Because we know sine 53 is k. That's what we know. We know that cosine 143 is minus k. Now we need to get cosine 53. What is this? Okay, so there are a couple of ways to do this. We know that if you have sine squared plus cosine squared theta equals 1. So you are looking for cosine theta, which is 1 minus sine squared theta. So which means that when you have cosine theta, then it is plus or minus. So it's plus the square root of 1 minus sine squared. Okay, it's plus or minus. But now you need to choose one of them. Okay, 53 is in the first quadrant because it is between 0 degrees and 90 degrees. So 53 is somewhere here. But all the trigonometric functions, according to the cast rule, all trigonometric functions are positive. So this is going to be positive. So you take the plus here, and then you put the square root of 1 minus the sign. Okay. Right. So there we go. Welcome, Tsenulo. Right. So now at this point, you know sine 53 is k. Sine 53 is k. So when you have sine 53 is k, so this is going to be like k squared. So cosine 53 is 1 minus k squared. Right, so that is the answer, but you can use a diagram as well. You can draw. We can draw like this and draw a triangle and do all that, okay? So yeah, it's a popular method, that one as well. So yeah, just note that. Okay, Tsenulo, let's just
Can
do
we
that.
please do it?
Tsenulo, you're here? So yeah, Tsenulo, we're gonna do both because I know that Tsenulo is interested in saying, all right, we're gonna do both. So we're gonna do both teaching mathematics and practicing math because we don't have time. So we're gonna do lots of past papers, lots of teaching the concepts as well. Next question. Okay, this video is gonna be available, so not worry that you found us in the middle, Tsenulo. Do not worry about that. Prove that this one is equal to sine theta. How do you prove this? So here you learned the left-hand side. It's this over that. So it is cosine theta, sine 2 theta, minus cosine 2 theta divided by 2 sine theta. Okay, I want to prove this one. How do we prove this one? Right, to prove this one, we proceed as follows. So we take the one side and produce the other one, okay? So this one obviously is just using identities. So sine 2 theta is equal to 2 theta cosine what? Cosine theta minus, what is cosine 2 theta? We can also write cosine squared theta minus sine squared theta divided by 2 sine theta. Cosine cancels and you have 1 divided by cosine cancels cosine, leaving us with that minus you have these, which is exactly cosine squared minus sine squared divided by 2 sine theta. So 2 sine theta is the LCD. So 2 sine theta divided by 2 sine theta is 1. By that, it's precisely a 1 minus this divided by that is 1. You multiply the numerator by that, so it will be minus cosine squared theta plus sine squared theta. Right, so we have this. You have exactly this here. Now, there are a couple of ways to do this one. What is this number 1? What is 1 the same as? 1. 1 is the same as sine squared theta plus cosine squared theta minus cosine squared theta plus sine squared theta divided by 2 sine theta. So the cosine cancels and your sine squared plus sine squared, which is 2 sine squared. So you divide everything here, and you have sine theta, and this sine theta is the right-hand side. Okay, the right-hand side is sine theta. So we have been able to prove this here, and this is how you need to prove this in the exam. Right, so there's some identities that you need to always remember. What are the identities? We call them the double angle identities. What are the double angle identities? Like if you have sine 2 theta is 2 sine theta cosine theta. What is cosine 2 theta? Is cosine squared theta minus sine squared theta. It is cosine 2 theta. These things are then at the back of the matric paper. Cosine 2 theta is also 2 cosine squared theta minus 1. Cosine 2 theta has 3 identities, is also 1 minus 2 sine squared theta. So these are 3 identities for cosine 2 theta. These are the double angle formulae we learn at matric. But also we need to know that the tan of 2 theta is the same as the tangent of theta divided by 1 minus the tangent squared of theta. We need to also know that if we're at metric level, we need to also know the compound angle formula for A minus B. What is the tangent of A minus B? The tangent of A minus B is the tangent of A minus the tangent of B divided by 1 plus the tangent of A, the tangent of B. Like that. So yeah, that's the answer. Okay, so we have proven this here. From the left, we got sine theta. All right, now what you need to do, obviously, to pay particular attention to this, make sure you understand the proofs. We are recording this discussion, so this is going to be available for you to watch and make sure that you make sense of these questions. So we move on to the next question. Calculate the general solution of this one. Give answer correct to 1 decimal place. So let's do this one. So now we have been given this. 3 sine squared equals 2 sine theta. So you write a 3 sine squared theta, then you transpose the other one, sine theta. You factor out the sine theta as a common factor. And you have 3 sine theta minus 2. Okay, this you multiply, it is sine theta is 0, or you have sine theta is 2/3. So what is then the answer to this here? Right, so at this point, at this, we get the following. When is the sine 0? You must get the reference angle. Right, so the reference angle is what for this here? The reference angle is 0 degrees, or the reference angle is 180 degrees. So which means that theta is equal to 0 degrees plus, right, the following. So you have 0 degrees here plus 360 degrees times k, where k is in Z. Or you can take theta to be 180 degrees plus 360 degrees times k, where k is in Z. We add multiples of 360 because of the period of the trigonometric sine function. This is the case, or now we're going to focus on the other one. The sine of theta is 2/3. So the reference angle here, the reference angle is arc sine of 2/3, which is 41.8 degrees. Right, so the sine is positive. You look at the cast diagram. Sine positive is positive in the first and positive here, which means theta is 41.8 degrees, but you add the periods of this, which is 360 degrees times k, where k is an element of Z. Theta equals, now you have this here in the other quadrant, in the second quadrant. So it is actually 100. It is 100 here. So 180 degrees minus 41.8 degrees plus 360 degrees times k, where k is in Z. So what is the answer to this now? 180 minus 41.8 is 138. 138.2 degrees plus 360 degrees times k, where k is an element of the set of the integers. So now this is the answer, and we are done. We are done. We are done. Next question. Okay, now we're looking at the Cartesian plane. In the Cartesian plane below, second center M is drawn. A is a point. A is a point on the x-axis. B is a point on the x-axis. Yeah, B lies on the circle and the x-axis. Okay, it's on the circle and the x-axis. Point C lies on the circle and the y-axis. Right, the equation of the circle is this one, x minus 3 squared plus y plus 1. This is the equation of the circle. And the equation of the circle is x minus 3 squared plus y plus 1 squared is 25. Line AC is a tangent to the circle at C. Line AC is a tangent to the circle at C. Tangent to this. Write down the coordinates of M. We want these coordinates. Okay, these coordinates are obvious. What are the coordinates of M? Anyone?
3 and -1.
Well done. The coordinates of M are precisely 3 and -1. We just read them off from the center. From here, we take this one because it's negative, we write 3, and because it's positive, we write the negative of that. So obviously, we can see this as follows and say it is y minus into -1, like this. Right, so you have 3 and -1, and that is the answer. Determine the coordinates of point C. How many marks? 3 marks. Anyone finding the coordinates of point C? I'm giving you
X
like
is 0.
I'm giving you like 2 minutes to find the coordinates of point C. How do we find the coordinates of point C? How? Where do we start? Anyone?
Hmm.
Too easy. What are the coordinates of point C? Okay, C is the y-intercept. How do we find the y-intercept of a graph? We let x be equal to 0 in this equation.
0.
Okay, good. So that's what we're gonna do. I can see that. Okay, I'm sure that Senul was thinking about it as well. But Waruna was as well thinking about this. Okay, guys, we need distinctions in mathematics this time around. Please, we can't falter. Right, want to get the y-intercept? And to get the y-intercept, what do we do? You let x be 0. You have this one. Which is 25 minus 9. What is 25 minus 9? 16. So which means, therefore, that you have y plus 1, you square this one. 16. Put the square root like this. And then you put plus or minus. So you can put this one to be plus or minus 4. Which means that at this point, what you're getting is that y is actually equal to, it's equal to 4 minus 1. Or y is, now you take the minus 4, you transpose the minus 1. Giving minus 5, giving 3. Right, so the coordinates of the point C, which one? Because now you have either 3 or minus 5. You need to choose. Which one is going to work for the point C?
3.
Well done, it's 3. So the coordinates of C will therefore become 0 and 3. Which means, therefore, at this point, the coordinates of C are 0 and 3. Like this. Okay. Next question. Okay, remember, we just had to find the coordinates of C. C is the point on the circle, so we use the equation of the circle to find the y-intercept of the circle. But obviously, this circle is producing two y values. So because it's producing two y values, the top one is 3 and the bottom one is minus what? Is minus 5. And the top one here is 3. Okay. Right, so we have this. Right, determine the equation of the tangent AC. Okay, the equation of the tangent AC. Anyone? Want to find the equation of the tangent AC? Anyone? Okay, I'm giving you 2 minutes to find the equation of AC. Okay, first I want to know, what is the gradient of AC? Anyone? What is the gradient? For us to find the equation of the tangent, we must find the what? We must find the gradient of AC. Anyone? What is the gradient of AC? Anyone?
No.
Tenulo, what do you think? What is the gradient of AC, Tenulo? I've heard Warun already.
No,
I've
it's
heard.
gone.
Please come again. Tenulo is gone.
Yes.
Yes. Oh my goodness. I did not realize. I know that Tenulo is quite.
Sure.
Right. So yeah, okay. I'm with you now. You are alone. So you're not supposed to be scared of anyone. In terms of answering the question. Right, the gradient of AC, because for us to get the equation of AC, we must know the gradient of AC. What is the gradient of AC? Right?
Should we first find the coordinates of A so we can find the gradient?
Yes, we need to. One way is to find the coordinates of A. Good, but how? Where do we start? I know it's easy, this question, but I'm trying to train your mind, you see, so that you can know how to navigate your way through the question. Right. Right. So yeah. Right. So we good. Right. So it's obvious this one. To find the gradient of AC is we proceed as follows. Right. So we need to first find the gradient, the gradient of this line here. Because you already know the coordinates of M, which are 3 into minus 1. And the coordinates of C we know. And we know that a tangent is perpendicular to a radius. Right.
Oh.
Right, so we're done with this question. Right, we're done with this question. So which means that we just have to find the gradient of CM. So you take C with the coordinates 0, 3. M with the coordinates 3, minus 1. X2, Y2. What is the gradient of CM? Okay, we use the formula Y2 minus Y1 over X2 minus X1. What is Y2? Y2 is minus 1, Y1 is 3. X2 is 3 x1 is 0, which is minus 4/3. Then now, what is the right? Right. So now, right. So now we just need the gradient of the tangent. The tangent, you can say the tangent AC. What is the gradient of the tangent AC? It is 3/4. The gradient of the tangent AC is 3/4. Why? Because now this one is a radius this. So a tangent is always perpendicular to what? A radius at the point of contact. So now, which means that now, but this tangent is passing through. Is passing through C with coordinates 0, 3. Y minus y1. M into x minus x1. Y minus, so this is x1, y1. Right. Right, so we're good. So what is y1? It is 3. This tangent is like this. So it is from the point A, but it passes through the point C. So the point C has x1, y1. So which means the gradient of this tangent is 3/4 into x minus, what is x1? 0. Which is 3/4 x plus 3. That is the equation. 3/4 plus 3. Right. So yeah, that is the equation of the what? That is the equation required of the
AC.
yeah, okay. The equation of the tangent is that one there because it is just perpendicular to the radius here. And this is here, and this one is m with the coordinates 3 minus 1. Right, so yeah, this is what we have. Next question. Determine the length of AB. Leave your answer correct to 1 decimal place. The length of AB. Let's see now. Where is AB? We need now the length of AB. The distance from here to there. Good. Nice question, examiner. What is the distance of AB? I'm giving you like 2 minutes to try that one, please. 2 minutes. The distance from A to B. How do you find the distance from A to B? Right. Right, we have that. Next question, what is the answer? Okay. What do you think?
Hmm.
Yes. Okay, look, you'd have this one. Let's first find the coordinates of A. A is the x-intercept. X-intercept of tangent OA. 3/4. That's 3. Okay, to find the x-intercept, what do? We let y be equal to what? 0. If y is 0, you have 3/4 of x plus 3. So if you solve this, you'll get that x is -4, meaning the coordinates of A are x is -4. We start with the x and then we write the y. The next thing now is you need to find the x-intercept of the circle. X-intercept of the circle. How do you find the x-intercept of the circle? You let y be 0 in the circle. Right. What is the equation of the circle? Squared plus y plus 1, which is equal to 25. You make y 0 here. So which means you have this one squared. 0 plus 1. You square this equals 25, which means x minus 3. You square this, and this is 25 minus 1, which is 24. Right, so you take the square root and you solve everything. Okay, so this is going to be 3 plus or minus the square root of 24. Now you can do this. Right, so to find a b, so you have this one. This is -4. And then okay, this is -4. What are the coordinates here? Right, so the coordinates would be, now you need to choose between these, but it's on the negative side. Right. So you're going to have that this one is 3 minus the square root of 24. Which means the distance now between these two, you need to subtract these here. So to subtract this one here, how to subtract these two numbers that are both negative? One way is to say 4 minus 3 that. And 4 minus 3 is what? Is 1. Okay, you might need to take the modulus of this as well. Right, because now you have this one is -4, and what is this one here? It's minus something. Right, so it's like minus 1.9. So yeah, you can do this. So it is the same as saying AB is 4 minus, then you have this one, which is minus 1.9. 4 minus 1.9. 2.1. So, yeah.
This is a long question.
It's quite a long question, isn't it? Okay, for the marks, yeah.
Mm,
For the marks. Right, because we did not know the coordinates of A. So we just found the coordinates of A. And therefore, you have the coordinates of we did not also know the coordinates of B, okay, because obviously that is the point A and that is the point B. So there are a couple of coordinates we did not know here. So but surely now we know, for instance, this we know it's A and that is B. It's quite a long question. Yeah, you can try to cut down the steps a little bit, but we just needed to find the coordinates of A and B to find the distance between them. Okay, so it's quite a long question. 4 marks anyway there. Okay, let's proceed. Okay, here's a question on the thing on sacral geometry. Prove the theorem that states that the angle between a tangent and a chord is equal to the angle in the alternate segment. Right, just to get the proof of this one. Right, to do the proof of this, you can decide we're going to prove that this one is equal to that one. So we're going to perform a construction. Right. So you have these. So you have this one is a diameter, so that angle is 90. What are you required to prove? CAE is equal to, okay, you can call this one F. Right, CAE is equal to, yeah, CAE is equal to ABC. That's what we want to prove. We want to prove that this angle is equal to this. So CAE, what are we required to prove? We're required to prove that CAE is equal to ABC. So we do a construction. To do a construction, you join AF through the origin. Join AF through the origin. And join. Now you proceed to join like FC. Right, so here comes the proof of this ten-chord theorem. We're proving the ten-chord theorem here. So which means that we can see that OAC plus CAE. OAC plus CAE, these two angles, so this one and this one, if you add them, we get actually 90 degrees. So OAC plus CAE, OAC. OAC plus CAE is equal to 90 degrees. Why? Because the tangent is perpendicular to the diameter. Tangent is always perpendicular to a diameter. So now what else do we say? Angle FCA. FCA is 90 degrees. For FCA equals 90 degrees. Why is FCA equals 90 degrees? It is an angle in semicircle. FCA equals 90 degrees, an angle in semicircle. Right, so there is also angle OFC. OFC plus OAC. OFC plus OAC is equal to 90 degrees, okay? Because already this one is an angle in semicircle, 90 degrees. So even these two angles, when we add them, we must get 90 because 90 plus 90 in the triangle is going to produce 180. They're angles in a triangle. So OFC plus OAC is 90 degrees. This is true because of the angles in triangle. Angles in triangle. Right, so you have these two guys now. If you compare the first and the third one, OAC is common, so which means that we can deduce straight away. CAE, OFC is equal to CAE. Why is this the case? But OFC, okay, we have found that OFC is CAE. OFC is actually equal to CAE. OFC is CAE, but I want to prove that CAE is this. So CAE is OFC. OFC, this angle is equal to this one. This angle is equal to this one because they're in the same segment. You have this here and you have this. Angles in the same segment. So this equals this. The angles in the same segment. So which means, therefore, this equals this.
Yes.
Right, so if this equals this, how do we write that one? So we're going to say that OFC is equal to ABC. But OFC is equal to angle ABC. Okay, so these two are equal. Thus, we have that these are equal, so which means that CAE is equal to ABC. Angles in same segment. Angles in same segment. Okay, this one. Angles in same segment, okay? Because we saw the angles like this. So this equals this. So angles in same segment. Right, so we have exactly that. We have exactly that there. Right. So we have exactly that. So I'm just removing this one here. Right, so with that said, now we continue. So we've been able to prove that CAE is ABC. CAE is ABC. CAE is ABC. All right. Here's another question. This one you're going to do it. I'm going to give you like a couple of minutes for you to do. In the diagram below, two circles are drawn intersecting at B and F. They are intersecting at B and F. They intersect at B and F, these two circles. CF is a tangent to the smaller circle. Must not forget that CF is a tangent to the smaller circle. A and G are points on the circumference of the smaller circle. A and G are points on the circumference of the smaller circle. Chords FC and BD of the larger circle intersect at E. The chords FC and BD. FC and BD. These are chords and therefore they're straight lines. They actually intersect at the point E. ABD is a straight line. ABD is a what? It's a straight line. Like this. Angle C is 70 degrees. Angle C is 70 degrees. Right, so angle C is 70 degrees. Where is angle C? 70 degrees. And angle D is 52 degrees. There, okay? Can see everything. We need to just do something small. We need to determine the size of the angle G1. We need to find G1. What is the size of G1? Let me bring my pen. We need to find the size of the angle G1. What is the size of G1? Okay, let me give you like 3 minutes to find G1. Let me know what you get. But you must not forget that CF is a tangent. This one. CF is a tangent to the smaller circle at the point F. Don't forget that.
Sir, I have a question.
Yes, please. What's your question?
If I find E3,
Yes.
does that mean E1 is the same as E3 because of revolution?
Yes. Yeah, E1 and E3 are the same.
Okay.
Yeah, I agree. If you find E3, then yeah, E1 is the same as E3 because those we call them vertically opposite angles. So if angles in X like these, they're called vertically opposite. Vertically opposite what? Angles, this. So yeah, E1 and E3, E2 and E4 are the same. Right, so, but we're interested in G1, right? This one here. Let me know what you think. Right. Right. Let me know when you're done.
Okay.
All right.
Okay, I'm stuck.
All right, let's just do it together. Right, obviously want to find the size of the angle G1. First things first, we're able to realize that this one angle here is because if you have a circle like this, and you have a butterfly that is like this guy equals this. So these are angles in the same segment. So if this is equal to this, so this must be 70 degrees. 52, this must be 52 degrees. So B3 is equal to 70 degrees. So first we realize that the angle B3 is equal to 70 degrees. Why is B3 equal 7 degrees?
Why is F2 52?
That's the thing. Okay, why is
Oh, I see.
you sure you're able to see?
I
Correct.
see.
Yeah.
Yes,
Okay,
yes, sir.
because of this kind of a reason, there's a butterfly thing here. Okay, I sometimes call these like the butterfly wings, and if all the wings have their vertices on the circumference of the circle, then it means that the angles are the same. Right, so F2 is also that. So the B3 is actually 70 degrees, 70 degrees angles in same segment. But also we have F2. F2 is equal to 52 degrees. Why is F2 equals 52 degrees? Why is angle F?
Angles in the same segment.
Yes.
And G2 will also be 52.
All right. Right.
Because of the tan chord theorem. No, it won't. Will
Yes.
it?
Okay.
Oh, okay.
Yeah, but yeah, what was my question again? I was asking why is F2 equal 52? Because of the butterfly thing, because this here is like a butterfly this. Okay. Right. So you have this equals this equals this. So if you have this equals this, so what do we get? Is this equals this? Okay, because of the butterfly. So F2 equals 52 degrees because of angles in same segment. In same segment. Next. Okay, so we have 70 and 52. This is therefore equal to this. So this is also that. Yeah, because this is like straight. This is a tangent.
Mm-hmm.
Okay. Obviously, I want you to realize the theorem that I'm using there. Right, if you have something like this in geometry, the angle that is here is always equal to okay, yeah. The
Okay.
reason is we say the exterior angle of a cyclic chord equals interior opposite angle. Meaning B3 is equal to G1, G2. Meaning actually G1, G2, angle G1 plus angle G2 equals 70 degrees. This is the exterior angle of cyclic chords equals interior opposite angle. Okay. So the angle here like this is equal to the angle there. So this one is equal to the angle there. Next, we have the angle F2 must be equal to the angle G2.
G2, which leaves G1 to equal 18.
Well done. Well done. So because this is like the Tenko theorem, because there's a tangent here, this F is a tangent. So you have that in Tenko means this. This guy is equal to this guy. So this one is equal.
Mhm.
The angle between a tangent and a chord equals the one subtended by this chord here. This chord subtends this angle. So this chord subtends this angle. So this angle is equal to 52 degrees. So that's what we then say here. F2 is equal to G2. So F2 is equal to G2, which is equal to 52 degrees. So F2 is equal to G2 equals 52 degrees. Tenko theorem. Tenko what? Theorem. Right. So what is then that? So that's G1 plus G2 is 70 degrees, which means you have G1. What is G2? It is 52 degrees equals 70 degrees. So G1 is 70 minus 52, which is 18 degrees. So G1 is equal to 18 degrees. So this is the answer. So now we have proven that G1 is equal to 18 degrees. So we can come to this shape here and state safely that this one is equal to 18 degrees. Is equal to 18 degrees. Okay. Next thing, we continue. Right. Let's do this one. Determine the coordinates of B. Okay, let's look at this one. Question 7, section B. In the diagram below, you have triangle AOC. AOC. Okay, triangle AOC has A with the coordinates 2, 6, 0, 0, or the origin coordinates 0, 0. O is the coordinates 0 and 0. Drawn. C is a point on the x-axis. AO is AC. E lies on the y-axis, and F lies on the x-axis. Line EF goes through the points B and D on OA and CA. The equation of EF is given by this. Right, the equation of EF is given by 2y plus x is equal to 10. Determine the coordinates of B, and hence the area of triangle EBO. Okay, of triangle EBO. Right, triangle EBO. So now want to find the coordinates of B. This one. Obvious. How many marks? 8 marks. Wow.
Yeah.
Okay, but yeah, it's very easy. The coordinates of B, what do you think? How can find the coordinates of B?
I think we can substitute A
Okay, first
into
we must
the
find the
straight line
equation.
equation.
Please come again.
Substituting A into the straight line equation.
You're using A. Right, so first we must find the equation of OA. And then because we already have this equation, so we just need the equation of OA, and then we find the point of intersection between them.
Okay.
Right. How do we find the equation of OA? It's obvious because we already know that the coordinates here are 0 and 0. Right, so what is the equation of OA? Right, you can even, it passes through the center, so let's just find the gradient to make sure we demonstrate the methods, but you can see that it's y over x. So it's y over x. So it's 3x, you can say, because 6 divided by 2 is what? It's 3. Then you just multiply by x because it passes through the origin. But you can just demonstrate the method and say this one is y2 minus y1 divided by x2 minus x1. x1, y1, x2, y2. What is y2? 6. What is y1? 0. What is x2?
0,
x1?
2,
0. Okay, that's
0.
fine. Giving 3, right? Okay. The gradient is 3 of OA. Then you want to find the equation. So the equation, obviously, OA passes through the origin. Right, OA passes through the origin. So if it passes through the origin, okay, Tsenulo is right back now. It passes through the origin. Okay, so we're gonna do both, Tsenulo. We can use mx plus c, but yeah. Mx plus c, so which means that it is y equals the gradient is 3x plus c. Right, if the gradient is 3x plus c through the origin, you would have that y is x and y this. So y is 0 and x is what? X is 0. which means that so y is 3x. Goodness me. This is the equation of OA. Right, we are dealing with the equation of OA. So if you look at this diagram, the equation of OA is y equals 3x. That is the equation of OA. Equation of OA is y equals 3x. And then we have the equation of EB of EF. The equation of EF is this one. So the two lines intersect, and therefore you need to solve the two equations simultaneously to find the coordinates of B. Right, so let's find the coordinates of B. Right, so the coordinates of B, you have y equals 3x, according to equation 1, and then the other equation is what? Is this one, 2y plus x equals 10. The other equation is 2y plus x equals 10. Call this one equation 2. Okay, you have a pair of equations to solve simultaneously. In which case here, you can say put equation 1 into equation 2, which means y is this? Y is 3x equals 10. What is 3 plus 1? 7x equals 10. Divide both sides by, divide both left and right by 7, getting x equals 10 out of 7. 10 out of 7. Okay. You have this. So what is y? Okay, to get y, you can use this one, which says y equals 3 times x. X is this one. So if you multiply by 3, it's going to become 30. And therefore, the coordinates of the point B are x is 10 out of 7 and y is 30 out of 7. Okay, now we want to find the coordinates of E. Okay, we're to find the coordinates of B, and we've just done that. So the coordinates of B here are 10 out of 7 and 30 out of 7. Given the coordinates of E. Okay. To find the coordinates of E, we let x be 0 because it's the y-intercept this. So x be 0 and then y is 5. Remember, I want to find the area now of the equation EBO. Next, we find the coordinates of
E.
Coordinates of E. How do you find the coordinates of E? Is the y-intercept, so you let x be 0. Okay, you have the equation is 2 y plus x is 10. Make x 0. Divide through by 2. The coordinates of E. X is 0 and y is 5. Okay, that is the thing. 0, 5. So if that is the case, you need the area which is half the base. The base is 5. Okay, because trying to cut down on the amount of work already. The distance from the origin 0, 0 to the 0, 5 point is 5 units. Okay, so we're dealing with the base of 5 units. The height is up to what y is here. What are the coordinates of b? Coordinates of b are these. So y is the second one. Rather, x is the height. So x is 10 out of 7. If we move horizontally, it's going to give us the height. So 10 out of 7 is the height of the triangle that is slanted. So 10 out of 7. So what is the answer? Okay, you have 10, you get 5. 5 by 5 is 25. The area is 25 out of 7 square units. And that's the answer. So the area of triangle EBO is 25 out of 7. And that's the answer. If D has the coordinates x and 18 out of 5, determine the area of triangle DCF. Okay, now they've given us the coordinates of the, okay, look. Here they said this was a long question. Determine the coordinates of B and hence the area. We found the coordinates of B to be 10 over 7 and 30 out of 7. And the area was found by using half base by height. The base of the triangle, this triangle here, the triangle is sitting like this. So the base is this side here and is from the origin to there, which is 5 units, and the height is x, the x coordinate, because you progress horizontally. Now we found the area. Now they're giving us the coordinates of D. They're saying the coordinates of D are x and 18 out of 5. The coordinates of D are x and 18 out of 5. Those are the coordinates of D. Okay, if these are the coordinates of D, what are we supposed to do? We need to find the area of triangle DCF. DCF. We need to find the area of triangle DCF. Right. So how do we find the area of triangle DCF? Right. We need to just be able to find this one here. Right. So in a couple of ways, what are the coordinates of the point C? And what are the coordinates of the point F? If y is 0, you get the x-intercept. This is the equation of the line. If y is 0, this becomes 0, and you're left with x equals 10. So x equals 10 when y is 0.
Okay.
Okay, and then now we found the coordinates of F, but we need the coordinates of C. We want to find the area of triangle DCF. We want to find the area of this triangle. So we can say base by height, but what are the coordinates of C? What can help us to find the coordinates of C? Right, so obviously there are a couple of ways to do this. Okay, now we want to find the coordinates. Want to find The coordinates of C. Right, what are the coordinates of C? Right, so the coordinates of C are pretty, very, very obvious, right? Because now to find the coordinates of the point C, you can actually determine those in multiple ways. In multiple ways. The coordinates of A are given and the origin are given, and you have the rest of these here. But you also have that AO is AC. AO is AC. AO is AC. So this triangle is isosceles, this. If this triangle is isosceles, it means that you can bisect it like this. At this point, you divide x by, okay, you know what x is here. X is 2. If x is 2, then it's going to be 4, 0 here. Right, so the coordinates of C, the coordinates of C are 4 and 0.
How do we know that x is 2?
Okay, how do we know that x is 2? Good question. Right, because we already know that the A has x and y coordinates and it is up there. So x is 2 and y is 6. But if x is 2 at A, it means that if you, it means x is 2 below A, directly below A at a point that is on a line segment that is perpendicular to to the x-axis. So that x is 2 here, x is going to be 2 there. Because with the x values come from this line, they come from the x-axis to go up first. Okay, to go up to other points. So x is 2. If x is 2, this side of the triangle is the same as this side of the triangle, because the examiner knew that we need that part. AO equals AC. AO equals AC, so that if this is the case, and then you get 4, 0. The coordinates of C are 10 and 0. We've already seen that. Because you already know the equation of this line. So when y is 0, x is 10. When y is 0, x is 10. 10, 0. Right, so we have a triangle like this. Here's the coordinates for 0. F is the coordinates 10, 0. We want to find the length of this. What is the length of this? Okay, this is going to be like 10 minus 4. Which is what? Which is 6.
6.
Yeah. So this is 6, and then we just need the height. But the height is already there. Okay, the height is the y, because we know the coordinates. This is the d with x and 18 out of 5. So which means the area is half base by height. The area. What is the base? 6. The height is 18 out of 5. What is half of these? Half of 6. Multiply everything.
3.
Half of 6 is 3. 3 by 18 is 54 out of 5. Units, square units, or units squared. So that is the area of that. So in other words, at this point, we have that the area of the triangle DCF is that one. The area of the triangle DCF, it's that one. So the area of triangle DCF is 54 out of 5. units squared. And you have this. Right, so that is the answer to that question. So just pay attention to that. Okay, so these are very hectic questions I'm doing here. They are demanding questions. So if you understand these questions, you'll be a star in the exams, okay? So we had to find the area of triangle DCF. Here is the triangle here. And we realized a couple of things. We had to find the coordinates of C, we had to find the coordinates of F, and then we can find the base. And then the height is 18 because the height is the Y component there. Okay, so we are good. Let's see another question. Right, here's the circle. In the Cartesian plane below, circle center, with 3, 1. 3, 1 are the coordinates of the center, is drawn. A and C are fixed points on the circle. A and C are fixed points on the circle. Here they are. We can see them straight away. A and C. Right, CAB is 30 degrees. This angle CAB is 30 degrees. There it is, 30 degrees. B is a variable point on the circle. B is a variable point on the circle. So in other words, the point B is a movable point. Determine the length of OC. Determine the length of OC. What is the length of OC? Obvious. So it's just
3.
2 marks. What do you think it is? You might be
3.
right. All right. That's the distance formula, right? So yeah, want to find OC. So yeah, the length of OC because the both coordinates are known. So this is x1, y1. This is x2, y2. We are looking at these from O to C. OC. So we start here. X2 minus x1 squared plus y2 minus y1. You square this. What is OC? What is x2? Is 0. x1, 3. Y2 is minus 2. Y1 is 1. You square these. 9 plus 9. What is 9 plus 9? 18.
18.
What is the square root of 18? You can leave it that way. Right. Or you can simplify as follows and say the number 18 is 9 times 2. Square root of 9 is 3 the square root of 2.
Mhm.
You can do that. Okay, so we just had to find the length of, we had to find the length of OC, and we have found the length of OC. The length of OC we have found. Next question. B moves along the circle until BC is parallel to the x-axis. B moves along the circle. Right, so B moves along the circle. Okay, it's a movable point, it's a variable point. So they said here, B is a variable point. B moves along the circle until BC is parallel to the x-axis. Until BC is parallel to the x-axis. So you move it until this BC is parallel to the x-axis. Next question. Write down the new coordinates of B. Okay, how many marks? 2 marks. Easy. Anyone? They're saying B moves. So we move B. We want to find the coordinates of the new coordinates of B, the new coordinates of B. B moves. In other words, it's experiencing a translation. So this is a transformation of the point. If the point B is moved and you move it like this, until such that this line here, this line BC is parallel to the x-axis.
Would be -2.
Please come again.
X would be -2.
Okay, there's going to be a -2. And the other coordinate is going to become what? I agree. So we move the point B such that it is going to be here. Okay, you move it like this. Okay, such that you have this. Okay, so in other words, I agree with you that you're going to have the same point. If it's parallel, it means that this is going to be parallel to this. So at this point, it means that the y value is the same. Right, so the y value here, it's going to be -2 there, and then it's going to also be -2 over there. Okay, what about the x? What about the x? So already you know that O is the center. O is the center. If O is the center, then you can be able to find the radius, so the distance from here to there. The distance from here to there, you know. So if the distance from here to there is known, the distance from here to there must be the square root of 18 units. So what is it?
Mhm.
Anyone? So what must x be so that now when you get the distance here, it is exactly that. So you can even use the distance formula if one is not sure. You can say, okay, x we don't know. And then now you know the distance from here to there. It's 18, the square root of 18. So you have O. You have the point B, 3, 1 there, and bx minus 2. X minus 2. Okay, we already know that this one is square root of 18. So, because it's the radius, this is the radius, because the radius is the distance from the center of the circle to the circumference. Now, if we know the distance is this, you can even guess this. Because this plus this, okay, you start this plus this, because this minus into minus this. So 1 plus 2 is 3. You square 3. You get what? You get 9. So what can this one be? So that this minus this also gives us 9 when we square it. So this must be a number such that when you subtract this minus this, you get a 3 or a negative 3. 3 minus what? So that you get negative 3 or plus 3. It's 6. But otherwise, you can use the distance formula and say OB. OB is a square root of 18 units because it is the radius. So this is x1, y1. This is x2, y2. x2 minus x1 squared. y2 minus y1 squared. So what is x2? Is x1 is 3. You square this plus y2 is minus 2, y1 is 1. You square this, then you put a square root. Then you square this. So x minus 3. So this one is going to give 9. Uh, 18 minus 9 is 9. So plus or minus x minus 3, you have plus or minus 3. 3 plus or minus 3. 3 plus 3, or x is 3 minus 3, which means x is 6, or x is 0. Okay, you could guess the answer straight away because you want the distance to be 18, square root of 18. So this is 1 plus, it's 1 minus minus, because, or you can say this one minus this. Minus 2 minus 1 is minus 3. You square, you get a 9. And then if you get a 9, you need another 9 from this and this. So it can only be 6. Or it can only be, it can potentially be, but it can't be 0. Can't be 0. So it can only be 6. Right. Why can't it be 0? Because the point B is not an intercept. So it can't have any of the coordinate 0. It's in the middle. It's just in the middle of space. So it means, therefore, the coordinates here, the new coordinates of B, which I'm calling B primed, are 6 and minus 2. So the new coordinates of B, which you call B primed, are 6 and minus 2. Calculate the size of, yeah, okay, what was the question? Remember, they said B moves on the circle. So the point B is actually a movable point. Until B is parallel to the x-axis, write down the new coordinates of B. You know, we found that the new coordinates of B are actually 6 and minus 2. We are done. We are done.
Okay, so I have to go.
You have to go.
Yes.
Okay, by the way, I just forgot. Yeah, the time is gone. I need to, because it's more than 2 hours now, right? All right.
It's
So
2
I'm
hours.
going to post a video in the next couple of minutes. So, yeah, Tsenulo, she must go because it started early in the morning when I was inviting you. So I'm going to send another message. Then we're going to meet again later on today. So you let me know if you'll join or not. Joining is optional, but I'm going to start another session again at about 6:30 today. At 6:30.
Okay.
Yeah, we're going to do more things. But at 6:30, we're going to be doing more math paper 1. Okay, because there are other things in paper 1 we need to do. Okay, so from 6:30 to 8:30 at night, we shall be doing math paper 1. So I'm going to send the link, but it's the same link, so you can join. Okay, thanks, guys. I will see you there at 6:30.
Thank you.
You can join. Okay, but yeah, I'm also going to be teaching from 6:30, just in case, teaching some of the concepts there, because we're doing past exams. But yeah, we need to teach as well so that you guys can understand the concepts. Yeah, okay. So
Okay.
Tsenulo, yeah, I know Tsenulo is fresh. He just joined now. All right, Tsenulo, we'll continue again after, just at 6:30 in the evening. Thank you, guys.
Thank you, sir.
Goodbye, goodbye.
Bye-bye.
Goodbye, Tsenulo and Waruna.